All right, so if we defined the sine inverse in a very particular way, the next thing is to do the other two of the big three. So that would be cosine and tangent. Although we're not going to go in that order, I want to do tangent first, and the reason is tangent is going to have, so right, define, so y is tangent inverse of x, means that our x value is going to be, whoops, not the sine, the tangent of y. And what we're going to do is we're going to do the exact same restrictions. So where y is on the interval negative pi over 2 to pi over 2. We're actually not going to use the two endpoints because the two endpoints would be undefined. And so we can't really reverse from an undefined, right? Sort of an infinite value. But still that same kind of quadrant 1 and then a negative version of quadrant 4. So right, quad 1, tangent inverse of a positive, and we'll do quad 4, tan inverse of a negative. So tangent is going to have this exact same setup. So if we try to reverse our tangent values, so let's take an example. So let's find tangent inverse of like positive 1. Now, here's one thing to consider. Tangent is going to be a little bit trickier, right? So this is the angle where tangent of the angle is positive 1. So we know that's quadrant 1. That's a Q. And our tangent function, right, so from a unit circle sense, should be the y-coordinate divided by the x-coordinate. So for sine and cosine, we can sort of read this pretty quickly, just reading our unit circle in reverse, sort of looking at our coordinates, x and y, to sort of get our cosine and sine values respectively. Tangent is based on, right, sort of stacks of the y and x coordinates. So we need to sort of work a little bit to try to figure out where these different like points are coming from. Now, something like positive 1 is not so bad, right? To get y value divided by x to equal positive 1. This means sort of obviously, right, that the y value has to be equal to the x value. And so if we're looking at our unit circle, which hopefully you sort of have in your notes, what that is going to mean for us is if we sort of look for this angle, that's going to happen at our angle pi over 4. Again, we only care about quadrant 1. This also happens for tangent in the third quadrant, but because we're restricting our definition here, we're only looking for that one position. So this is going to be pi over 4, right? The sort of setup here would be, right, if I did, just as a reference, tangent of pi over 4, the like y over the x, they would both be root 2 over 2. And the idea is, well, those are the same, so they would reduce down to 1. So to do our tangent inverse, we have to kind of mentally prepare a little bit and like know what to expect, to sort of know what kind of values we get from the tangent function. It could be a good exercise to sort of just like spend a couple minutes, maybe more than once, just going through and sort of calculating tangent values, just so you know what to expect. In general, what we're going to get for tangent values would be either 0, positive or negative 1, or we're going to get sort of a root 3 over 1, which would just look like root 3, or you end up, in the other instance, you would end up with sort of a 1 over root 3, which would sort of rationalize and become root 3 over 3. So there's a couple values here that are maybe not so obvious. Let's do, just as another example, tangent inverse of root 3. Let's just see if we can sort of work this out. So this is the angle where tangent of the angle is supposed to be root 3. So in theory, right, that would be root 3 over 1. And so the idea is that should really sync up with a y value divided by an x value. That's really kind of what we should be doing. And if we look at our unit circle, again, hopefully you sort of have it handy in your notes. I don't want to have to flip back and forth between them. So what you're going to see is at what would be sort of 60 degrees, right? What would be sort of pi over 3. What we have here would be a root 3 over 2, and the x value would be 1 over 2. So what happens when we stack these and find the tangent values is all of the denominators for the fractions in the unit circle are 2. So all of those denominators are going to cancel each other out. So I'm really just sort of looking at the numerator positions. And so a tangent inverse of root 3, so where the heck is the angle where the tangent ends up is root 3. So that means I need really a root 3 over 1. And so if they're both over 2, that's going to work out. So the angle where that happens is pi over 3. So this is the y coordinate is root 3 over 2. The x is 1 over 2. You know, to a certain extent, I suppose the other version, the pi over 6 version, what you would get is, let's do a negative version. So the result is going to be root 3 over 3. So this is a little bit, this is sort of extra confusing. Like I was sort of saying before, I want an angle where tangent of the angle ends up as root 3 over 3. And so this is like, we really need to think about this for a minute. What's going on here is this is kind of like, okay, you know, what the heck could we have like started with? And the sort of not obvious answer is this is going to be the same thing as 1 over root 3. In some sense, if you sort of unrationalize and multiply both the top and the bottom by root 3, you can kind of unrationalize and get this back in the bottom. And so this could become a 1/2 over root 3 over 2. And so if this is supposed to be my y over my x, that's going to happen for us, right, at versions of pi over 6. If this is supposed to be negative, then that means the answer here would be negative pi over 6. So the short answer here is tangent, especially if you're not just at the 45s, just is tricky. It is a little confusing. You really need to sort of work to find them. It's a benefit to just sort of make yourself a little table, just sort of practice figuring out when you're going to get each of these two values as your answers. That's going to be sort of time well spent. Cosine inverse. So why the heck didn't we do cosine inverse yet? Cosine is usually our sort of number 2 of the big 3. So why is cosine inverse of x, right? So this means our x value is the cosine of y. And so what we're going to do here is we're going to define this on a slightly different range, a slightly different sort of angle span. And if we do this for a minute, if we sort of break down the quadrants, quadrant 1 kind of obviously, right, is our place where everything is positive. So quadrant 1 is a great place to get an inverse value of a positive for cosine, sine, and tangent, just like no questions. If I try to do the same quadrant 4 thing, however, cosine is positive down in quadrant 4, so I can't use the same sort of positive and negative versions of the same angles to get my answers here. That's just not going to cut it. So maybe the next best thing, so what quadrant is sort of near quadrant 1 where I could get negative angles? And the answer for cosine is going to be quadrant 2. So cosine function is negative in quadrant 2. And so what I'm going to do is I'm just going to get, right, angles from 0 to pi. 0 to pi over 2 for my positives, pi over 2 to 1 pi for my negatives. So if I was trying to sort of answer a question like, okay, so the cosine inverse of like positive 1/2. Where's that going to happen? So if we check our unit circle, this is going to happen at the angle pi over 3, or sort of 60 degrees, is where the cosine function is 1/2. If I do a negative version, cosine inverse of negative 1/2, what's going to happen here is I want a quadrant 2 angle. So what's the quadrant 2 angle where my cosine is negative 1/2? So it's going to be sort of the reference angle, right? It's going to be the same kind of position, the equivalent position as my positive 1/2. So it's the sort of quadrant 2 version of pi over 2. So that's going to, I'm sorry, pi over 3. So that's going to be 2 pi over 3. And so it's a quadrant 2 angle. So my cosine inverse is going to spit back exclusively positive values. So either quadrant 1 angles for my sort of positive versions, or it's going to give me quadrant 2 angles for my negative versions. If we just do sort of like one more quick example, right? Cosine inverse of, I don't know, negative root 2 over 2, right? So that's going to happen at the sort of version of 45 degrees in quadrant 2. That's going to be for us 3 pi over 4, quadrant 2. So cosine inverse is a little bit unique. Sine and tangent sort of operate under the same kind of guiding principles, the same sort of rules as far as which values go where. Cosine is a little bit different, but that's only because the cosine function doesn't give us negative values in quadrant 4, so we have to change our setup just to be able to sort of hit all the possible numbers. And that's what we're working with.